Running, like all voluntary movements, begins with the nervous system. First, an idea of the desired movement is formed in the prefrontal cortex. Within the premotor cortex, the thought and actions needed to take place for the desired movement are organized. Next, in the primary motor area, the action potentials are sent to the upper neurons by a signal that travels from the cerebral cortex to the brainstem and spinal cord, initiating the desired movement. Finally, lower motor neurons send inhibitory action potentials to the antagonist muscles to keep them from opposing movement, and excitatory action potentials to the agonist muscles, thus executing and completing the desired action. The brain is also very involved in the process of pushing oneself during a run. In such cases, the body is being pushed to the point that its physiological homeostasis is being significantly disrupted. The brain becomes worried that the activity at hand will be detrimental to the health of the body and urges the runner to stop running. This is why it can be difficult to push oneself during a high-intensity or strenuous run, as the brain is actively urging its body to stop running in an attempt to return the body to a safe homeostasis as quickly as possible. Lastly, during and after a run, the body has a significant increase of positive neurotransmitters that have been released from the prefrontal cortex and limbic regions of the brain. The release of norepinephrine results in an increased alertness, which is why some runners experience high clarity or focus while or after running. Additionally, serotonin, endorphins, and endocannabinoids are largely responsible for a term known as runner's high, where people experience a sense of euphoria and elevated mood during or after finishing a run. Many muscle groups are active while running. Firstly, the quadricep muscles, made up of the vastus medialis, vastus intermedius, vastus lateralis, and rectus femoris, are found stretching the space from the hips to the patella on the anterior of the leg, the region commonly known as the thigh. These muscles are responsible for the straightening, stabilizing, and extending the knee, as well as absorbing and dispersing the impact of the feet as they hit the ground. The biceps femoris, the semitendinosus, and semimembranosus all make up the hamstring, which spans from the hips to the knee and is posterior to the quadriceps. These muscles help with the flexing of the knee and extending of the thighs. Next, below the knees on the posterior of the legs are the gastrocnemius and the soleus, which make up the couple of muscles commonly known as the calf. These muscles help with providing power when a runner pushes their foot off the ground, the extension and flexion of the foot as the runner lands and pushes off, and reducing the impact when a runner lands. These muscles also help the ankle flex, provide some movement around its joint, and stay balanced. There are also many muscles besides those in the legs that are important in running. The iliopsoas, made up of the iliacus and psoas major, and commonly referred to as hip flexors, are found on the anterior of the body, mostly superior to the thighs. Where the iliacus only spans from the pelvis to the top of the femur, the psoas major is attached to the thoracic and lumbar vertebrae down to the femur. These muscles help stabilize the hips and pelvis, maintain good form, and work with the anterior leg muscles to keep the legs moving. Next are the gluteal muscles, which are found on the posterior of the body, in the buttocks, and are made up of three muscles: the gluteus maximus, the gluteus medius, and the gluteus minimus. These muscles aid those around it by helping stabilize and extend the hips, helping keep good form, and stabilizing the legs and knees. Although the group of muscles commonly referred to as one's core can include a variety of muscles, the most basic and commonly used muscles of the core are the transversus abdominis, rectus abdominis, and the internal and external obliques. These muscles are found on the anterior of the body around the stomach and are very important in maintaining posture and increasing the energy efficiency of the runner. Lastly, strong back muscles help maintain posture. The shoulders allow for the swinging of the arms and flexing of the elbows, and the arms, specifically the biceps brachii, bend and swing the arm. This swinging of the arms helps propel the legs forward because of the mechanical counterbalance of the momentum of one's legs. Here is an explanation of these muscles in action. First, the quadriceps are responsible for the flexing of the hips in order to lift the feet off the ground. From there, the hamstrings and gluteal muscles allow the hips and thighs to extend. Next, the hamstrings and quadriceps work together to both extend and flex the knee. The calves are then responsible for the extension and flexion of the foot as it lands and pushes off, reducing the shock impact as the feet hit the ground, and providing the power to push the feet off the ground. Along with the help of the hamstrings and quadriceps, the hip flexors are in charge of moving the legs back and forth. The quadriceps, glutes, and hip flexors all work together to ensure the stabilizing of the body's legs, hips, knees, and pelvic region while running. Next, the shoulders and arm muscles allow for the bending and swinging of the arms to keep rhythmic motion and to help propel the legs. Finally, the back muscles help maintain posture, and strong abdominal muscles can improve the energy efficiency of the runner. These systems work hand in hand when running. When someone begins running, their muscles require an increase of ATP in order to power their increased activity. This increased demand in ATP corresponds with an increased need for oxygen, and therefore the body will respond proportionally to the demand of oxygen. If the increased activity is minimal, the body will respond minimally, only increasing the heart rate slightly. But if the activity is highly rigorous, the body will respond accordingly with a significant increase in heart rate. This increase in heart rate is not enough on its own, however. Because the body needs more oxygen delivered to the muscles, the body needs an increase in available oxygen as well. Therefore, when a person begins running, both the heart rate and respiratory rate increase to match the increased need of oxygen in the muscles. The body is able to re-oxygenate blood by the following process. The oxygenated blood from the body is pumped to the right side of the heart, moving from the superior and inferior vena cavas into the right atrium, through the tricuspid valve into the right ventricle, and then through the pulmonary semilunar valve to the pulmonary arteries. The pulmonary arteries then split and deliver the deoxygenated blood to the lungs. There, inhaled oxygenated air collects in the alveoli of the lungs and is diffused into the bloodstream, therefore oxygenating the blood. From there, the blood is brought back to the heart via the pulmonary veins and into the left atrium, through the bicuspid valve into the left ventricle, and then is pumped to the rest of the body through the aortic semilunar valve and aorta. The process does not change when a person begins running, just its frequency. When a person is running, the body's demand for oxygen in the muscles is higher, so the body responds accordingly by increasing heart and respiratory rate. When the running is over, the demand for oxygen will return to normal, and the body will respond by slowly reducing the heart and respiratory rate. Therefore, after running, your heart will continue to beat quicker than usual, and your breathing does not automatically slow to its normal pace. Your body will require a recovery period in which both rates will slowly return to normal. Similarly to heart and respiratory rate, when running, your body responds by releasing up to 10 times as many immune cells as usual to fight off any present pathogens, and after finishing the run, will slowly decrease until it returns to normal. Unlike the other rates, however, immune cells then decrease to below normal levels, sometimes sinking to about half their usual count. Although there has been some misinformation pertaining to what this entails, this decrease in immune cell count is not actually detrimental to one's health. The decreased cell count occurs because the immune cells are now traveling through the bloodstream to check for infections in a process known as immune surveillance. When a certain activity is repeated consistently over a period of time, an increased number of neurons will attach to a given muscle. This attachment leads to a stronger response when neurons are fired, and therefore a quicker message to the brain. In the context of running, this means that the more often and consistently a person runs, the more neurons that will attach to the muscle used, the faster the message goes to the brain, and the faster the corresponding movement. Additionally, running, especially an occasional fast-paced run, leads to the secretion of a substance called brain-derived neurotrophic factor, also known as BDNF. BDNF can help regenerate neurons throughout the entire nervous system through binding to receptors in synapses to improve voltage strength and motor learning. Lastly, consistent exercise, not limited to but certainly including running, has been proven to significantly positively affect many mental illnesses, such as depression, anxiety, ADHD, PTSD, and many more. In addition to aiding mental health, such exercise has also been linked to improving memory, sleep, self-esteem, and overall mood, as well as relieving stress. After a strenuous activity such as running, muscles often suffer from microscopic tears from the stress of the exercise. This muscle trauma activates satellite cells, which congregate at the injury sites, fuse to the muscle fibers, and either remain as organelles on the muscle fiber, contribute more nuclei for the muscle cell, or differentiate to form new myofibrils. This leads to the repair of the damaged cell, replacement of destroyed cells, and an increase in myofibril count and thickness, leading to an increase in muscle mass. This repairing and increasing of mass makes the muscle stronger so that previous activities will take less energy to repeat post-cell repair. In addition to aiding overall health and decreasing weight, running has many benefits that are directly related to cardiovascular health. Running can help decrease blood pressure, lower cholesterol levels, lower risk for heart disease, reverse insulin resistance, increase in endothelial progenitor cells in the blood, and many more positive contributions to one's health. Running also positively alters the structure of the heart and its vessels. Blood vessels will adapt over time to have a greater vascular density and a greater vessel dilating capacity, and the walls of the heart will often grow thicker with cardiac muscle, which in turn helps strengthen the walls of the heart, therefore efficiently pumping more blood, increasing cardiac output, and increasing oxygen levels in the blood. Over time, the endurance capacity of the muscles active in respiration can improve, leading to more efficient and deeper breathing during exercise. With more running, your body will develop more capillaries, allowing blood to arrive to muscles quicker. Lastly, running can increase the capacity of the alveoli of the lungs, meaning that more oxygen can be collected after inhalation and diffused into the bloodstream. Running can improve immune health by reducing unnecessary inflammation within the body and has been rumored to help slow down the aging process as a whole. Additionally, running has been proven to strengthen the immune system, especially the adaptive immune system. It has been found that frequent activity significantly increases the body's T cell count and has improved its immune response to vaccination.
Running is nice. Running is good. Running is healthy. My wish is be running faster when I go up a hill. Running because I'm fast. And I like running because I like doing something. And I run and I want to have races, have fun, and do whatever I want to run.